a few additional identities here to look at, and also some problems that involve inverse sine and inverse cosine. Let's take a look. Here I want to evaluate the sine of arc sine 3/5 minus arc tangent 2. Know that this notation here is the same as inverse tangent, like sine with a little minus 1/3. Well, I'm not sure. This looks like a pretty complicated expression. This is just an angle. So I'm going to call that what it is, an angle. I'll just say that's angle A. And then this I'm going to say is angle B. And that means that my expression is really the sine of A plus B, which I know from my expansion formulas is going to be sine A cosine B plus cosine A sine B. So let's see if we can find the sine and cosine of A and the sine and cosine of B. So I'm going to go back up here to my original problem, and let's look at angle B here. I'm going to draw a little right triangle. I'm going to call this angle B, and what I know about angle B is it's the angle whose tangent is 2. So how am I going to fill in the sides here so that this angle B has a tangent of 2? Well, if I let this be 2 and that 1, then the opposite side over the adjacent side comes out 2 over 1, or 2. That means that this side by the Pythagorean theorem is going to be 2 squared plus 1 squared, which is 5, the square root of that. So that becomes square root 5. Okay, that means that I can fill in a little bit of my formula here. I know that, well, I don't know what sine A is, but cosine of B is 1 over square root 5. Plus cosine of A, I don't know what that is, but I do know what the sine of B is. It's going to be 2 over square root 5. Okay, so I have that filled in. Let's go back up and see if we can find sine and cosine of angle A. Let me draw in a little triangle right here. I'll label this with A. Here is my right angle here, and A is an angle whose sine is 3/5. So I'll label that 3 and that 5. So with respect to my angle A here, the opposite side is 3 and the hypotenuse is 5, giving me a sine of 3/5. Okay, that means by the Pythagorean theorem that that must be 4. Now I can fill in the rest of my numbers here. The sine of A, sine is going to be 3/5. Cosine of A is going to be 4/5. And I have all the numbers filled in. The rest is just arithmetic for the rest of this problem here, which is pretty easy for me to do. Might want to rationalize the denominator. Depends. I'd check the answer in the back of the book first to see if you need to or not. But the thing to remember about this notation for arc sine and arc tangent is it stands for an angle. So if you get a complicated expression like this, you can let this be angle A and this be angle B. Now your expression's a little simpler to look at. I see it's an expansion formula. Now I just need to know these individual things, so I go back and look at the information that I've given, draw these little triangles, and I have those numerical values. Let's look at another problem. I want to find the tangent of the inverse sine of x. Well, let's see what this is. Let's let this be angle alpha, and so what I'm looking for is the tangent of just angle alpha. Well, let's see what we know about angle alpha. Angle alpha is the inverse sine of x, means that alpha is an angle whose sine is x. Well, if I label this side with x, let's just make that the right angle. If this is x and this is 1, then the sine of alpha is x over 1, which is just x. So alpha is the inverse sine of x. So if this is x and this is 1, this side, by the Pythagorean theorem, is going to be 1 squared minus x squared. So the tangent of angle alpha, I can fill that in just using a little right triangle trigonometry right here. The tangent of alpha is going to be the opposite side over the adjacent side. So that's going to be x over square root 1 minus x squared. And let's just assume that angle alpha is an angle in the first quadrant, and we don't have to worry about it being in some other quadrant and having to use a plus or minus sign here, or maybe some absolute values. So if alpha is an angle in the first quadrant and is equal to inverse sine x, I can draw this little diagram right here. I see that this side is filled in by the Pythagorean theorem. I go back and see what I'm looking for, tangent of alpha, and it's very easy to fill in here, opposite over adjacent, and so I have this expression. Let's look at one more problem. we want to rewrite this expression right here, which is a sum, as a product. So I want to write this expression, which is addition, in terms of multiplication. Now, these are a little more, I would say, obscure identities, so I don't usually have my students memorize them, so I'm going to tell you which identity to use. Use the identity sine alpha plus sine beta is 2, sine alpha plus beta over 2, cosine alpha minus beta over 2. What's nice about this formula is it takes addition and rewrites it as multiplication. And so that's what we want to do. We want to take this sum and rewrite it as a product. So alpha is 7x, beta is equal to 3x. This is going to be equal to 2 sine of 7x plus 3x over 2 cosine of alpha minus beta over 2, 7x minus 3x over 2. And so that will be 2 sine of 7x plus 3x is 10x divided by 2 is 5x. Cosine of 7x minus 3x is 4x divided by 2 is 2x. So there is the same expression, sine 7x plus sine 3x, rewritten as a product, 2 sine 5x times cosine 2x. And again, I don't usually have my students memorize these formulas, so I put it up here for you to use. So we want to write this sum as a product using this formula right here. So that's a look at some of the additional identities in this chapter.